Good evening. You are very few now. The rest of the people are exhausted, I presume. Devin. I'm asking, are you tired?
No, we are not.
Okay, it's because you didn't participate that much.
We are listening. You want the explanation?
Okay. Then what we'll do is I'll recap what we've just talked about. If there's anyone to join, they'll find that whatever it is I'm talking about, I've already talked about. Is that okay?
Yeah. Yes, sir.
Okay. So we were looking at chemical formula for compounds, which we said the chemical formula is an abbreviation for a compound. It shows the symbols and the ratios of the atoms of the elements in a compound. That's what we said. For symbols, it's very easy because just check them out from a periodic table. But for this one, you need a bit of some skill. You have to understand oxidation numbers or valences for you to know how to write a chemical formula. The other skill is if when a formula is given to you, you must also be able to name it. It's a skill that is expected from you. So then we explained that by ratios we meant if you have sodium chloride, which is NaCl, the ratio, you have 1 sodium atom per atom of chlorine. So you have 1 sodium, 1 chlorine in the formula, 1 sodium ion and 1 chloride ion. And the ratio there is 1 to 1. And what was emphasized is that the number 1 is not indicated. You do not indicate the number. Then for a formula, e.g. water, which is H2O, there it contains 2 hydrogen atoms per atom of oxygen. So that what means that now the 2 there must always be written as a subscript. A subscript is a what? A number that you write after another number, just below the number. So for us in chemistry, the subscript is very important. I think someone had asked to say, what is a subscript? It's simply that. So meaning even when you have something as big as sulfuric acid, which is H2SO4, The hydrogens are 2. Instead of writing them separate, you write the subscript, which is the 2 there. And the 4 oxygens, you just put a 4 below. Not the way it is appearing. I think this is a copy-paste problem, but you can work it out, I know. So the explanation is here to explain the formula. The Na is indicating the element sodium. The Cl is indicating the element chlorine. NaCl means for a molecule of sodium chloride or a formula unit of sodium chloride, we use molecule because it's easy to use. A formula unit of sodium chloride or a molecule of sodium chloride will always contain only one sodium atom and one chlorine atom, one sodium ion and one chloride ion. So this is different for sulfuric acid. You have 2 hydrogens, 1 sulfur, and 4 oxygens. So it means these are the numbers of atoms in a molecule. So if someone said, how many atoms are in H2SO4? It will be 4 plus 1, which is 5, plus 2, which is 7. So a molecule of H2SO4 contains these numbers of atoms. So there's the ones that we indicate even on the periodic table there. If you just write Ca, it's indicative of an atom entering a reaction. So that's the reason why you've heard me mention that. Then for this one, Cleopas, you've raised your hand.
Yes.
Yes.
I wanted to find out how we can indicate the ions, like how you are saying about atoms, they are on subscripts. Now when it comes to ions.
I'm not getting you.
I'm saying I want to know how we can indicate the ions, since the atoms are being indicated as subscripts. Now when it comes to ions.
Thank you very much for your question. NaCl, this is an ionic compound. This is an ionic compound. I'll explain how you write them to indicate that these are ions. But for this, for us, this now is neutral because Na is +1 and Cl is -1. So these cancel. So there's no need of indicating the ions per se. So that is the explanation. But we'll explain, like when we come to bonding, when you're drawing Lewis diagrams, I'll show you how to indicate the ions to show how the bonding has taken place. So when you get to bonding, that's when it becomes very key. Infinix Smart 4, your mic is on data. For this one, the nitrate ion, this is a polyatomic ion. I hope this is what our friend wanted to find out from. This is a polyatomic ion, meaning it's an ion that contains more than one atom. So this one, the nitrate, will always be written as a single entity, NO3. I'll give you a table for polyatomic ions, which you'll be using. So this means you have 2 nitrate ions here. So you always have to put it in brackets. But if someone asks you to calculate the number of atoms, you say 2 times 3, which is 6, plus 2 times 1, which is 6 plus 2 is 8. So there are actually 9 atoms here. There are actually 9 atoms here. So this one will always compress because the polyatomic ion must always be written as a single entity. We'll get to polyatomic ions as I explained. So please do not panic. Do not panic to say, what's a polyatomic ion? It's like carbonate. I'm sure you've come across them. Even sulfate, this one is a polyatomic ion, the sulfate, except it was bonded with hydrogen. If it was bonded with something else, you would have indicated brackets right there. outside the SO4 and put a number there. So these are the things, the skills that you are expected to know. So now, guys, so we've already explained. I was making a mistake. That's why I've retouched this so that the video does not embarrass me a lot. But the only problem was there was internet problem, like internet just blinked and Zoom closed. It's that sensitive. So now, what I'm trying to say is that these are subscripts. Then don't confuse them with a prefix. A prefix is a word before another word, like midi, centi, those are prefixes. But subscripts are numbers now for our chemistry. So now, we're looking at compounds. What are the characteristics? So the compound number one, it contains the symbols of all the elements. So you can't have a compound, then you vomited some elements. And that's what some people do. You've asked for sulfuric acid, then they write hydrogen sulfide. Then they come to you and say, no, sir, natural oxygen, sure. What is there is that you have made a very big mistake. You have made a very big mistake. So make sure that you indicate all the atoms. That's the way it is in their ratios. So the numbers, number one is not used as a subscript. That's number two. If there's number one like NaCl, you don't use it. Then if there's a number more than one, you use it to indicate it, e.g. H2O. That's the concept for number three. Number four is just emphasizing that a polyatomic ion, you write it as a single entity. And then if it is with something that has oxidation number one or valency one, which is like Na, hydrogen, when it is with that, you only indicate it like that. Valency is the combining power. We'll talk about those things when we come to oxidation. But I'm saying if it's combined with like this one is combined with a group 1 element. So as long as it's combined with a group 1 element, there is no show of any number, like the number for NO3 is still 1. So there's no need of brackets. But now when it's combined with calcium, you put the brackets there and 2. Why? Because with calcium, you need 2 nitrate groups to bond there. So this is how you write calcium nitrate. So always try to understand that a polyatomic ion will always be considered as a single entity. So that's the way it is. Then the last point is just to say, when you are writing formulas like this, you do not actually show the arrangement of atoms in space. To know the arrangement of atoms or to know the shapes of the molecules, you have to go in details in molecular bonding and ionic bonding, especially molecular bonding because molecules have different shapes. But then we don't do that when you're just introducing here, unless we get to that topic, if we'll get there. So now, the other point was on the composition. We said that a particular compound always contains the same elements in the same proportion by mass. For example, water always contains 11.2% hydrogen and 88% oxygen by mass. So I was telling your friends that we actually don't ask you to say something about the composition of compounds. I'll just say there's water from Nova Scotia. I was telling you yourselves, water from Nova Scotia, and the other water is from Nairobi, Kenya. And then there's also water from Lusaka. Which one has the highest composition? Because Navika Motuma places, someone will forget. Just someone will forget and say, here ku Nova Scotia, ilafula. So those are the things. So you say the water from Nova Scotia will have a higher composition by mass. And yet, we have already explained that as long as it is water, the percent by mass is fixed. The next point was we defined natural law. Why did we define natural law? Because these two laws that follow are natural laws. So natural laws are simply summaries of general observations regarding nature. So those statements that summarize general observations regarding nature are called natural laws. Then this is how you define it. It's anything that is a generalization is a natural law. A principle or body of laws considered as derived from nature. So these ones, there were even examples, even religion is a natural law. So these are the things. Now for us, the two natural laws that we defined are the law of definite proportion. What I meant was some of you can word definite, definite. It also means fixed. So if you want to simplify, you can also be just saying fixed. No one will penalize you. In fact, will be excited because you are actually using the right words. These two, definite and fixed, are synonyms. So the law of definite proportion states that a compound always contains two or more elements chemically combined in a definite proportion by mass. Meaning the proportion, like they are fixed in the same ratio. If you just know the percent by mass for a compound, there will not be need to calculate furthermore when you are given the same question again. Maybe you just show it to show the working, but the percent by mass will always be fixed. Meaning if you're calculating the percent for water and then you find something other than 11.2%, it means there's a problem with your solving. You can actually review to say, I saw somewhere it was 11.2. So the percent for a compound is always fixed, regardless of the place, regardless of the size. Even if you have 2 milligrams of water, 7 milligrams of water, 50 kg of water, all of them will contain the same percent by mass. That's what we mean when we say law of fixed composition. The composition is always fixed. Law of multiple proportion states that two or more elements can combine in different ratios to produce more than one compound. What this means is that if I was explaining to say, look at hydrocarbons, thousands and thousands of hydrocarbons, and yet they contain only carbon and hydrogen. You have methane, ethane, propane, butane, and even the alkenes and the alkynes. All of them just contain carbon and hydrogen. And then when they enter reactions, their reactivities, their usage are different, and yet they contain the same things. The other one was you can't quench your thirst with hydrogen peroxide by comforting yourself to say, kai ikwata hydrogen na oxygen, then na water na NiDH2O, so chino. It would be like a short way of saying I don't want to live on this earth anymore. So try to think from that perspective, guys. So that's what it means from the law of multiple proportions. So now the summary of the laws are like this. So the laws state that the composition of a particular substance will always be the same, no matter what its origin is or how it is formed. So whether yakune voskosha nangubapangira menshi mulabu yapangika makumbi, percentage should be the same. Then number 2, the composition of different compounds formed from the same elements will be unique, e.g. carbon dioxide, carbon monoxide. Carbon dioxide is useful. Our plants use that to photosynthesize food. In our nature, carbon dioxide is the reason why it is hot. That's why you heard that if when you cut green plants, it becomes too hot because green plants help to absorb the excess carbon dioxide and use it to make food. Now, when you cut it too much, it means outside now there will be carbon dioxide in abundance, and it will contribute to what is called global warming. But if there's a balance, it's very useful because each kabili also to fire each kabili is very useful. But carbon monoxide, which is also made from carbon and oxygen, is not as useful. What do we mean by it is not as useful? It's because carbon monoxide is poisonous. When you are presented with carbon monoxide and oxygen, the ion in our blood will attract the carbon monoxide, which kills, and not the oxygen, which supports life. It's like the way it is, like someone you would rather lead a life in beer alcohol, which is destroying your liver, than for drinking in water or soft drinks. You will say, "I know shanwa mesh tunwa for alcohol." You have a higher affinity for alcohol than the water which supports life. It's the same with carbon monoxide and the oxygen. Our ion loves the poison, so you must not be presented in it. Those of you who have braziers, you find yourselves choked. There are so many people who have died from carbon monoxide poisoning. Why? Because there was incomplete combustion of charcoal. So those are the things you must reason from. So guys, these are the stuff. The last thing is we look at, and this is the only thing that remained before that spark. But I've loved my presentation because I took it like that one was a rehearsal to teach you a bit well and summarize it. I'm not doing it for you. As I've told you, I'm putting the videos on YouTube soon. I've got a YouTube page. So just search Chilungu Kandulo. You'll find the YouTube page there. You'll find I've even put 3 Zoom meetings there in alphabetical order, especially the one that we from doing. Even this one I'll put very soon. Because this table is just summarizing what we've said, that copper 1 chloride and copper 2 chloride are different. Even the way they appear will be different. So these are the things. Methane and octane are also different. Methane must be a gas, it's a gas. Octane is a solid, different, but they are formed from carbon and hydrogen. Alcohol inachosanda pa alcohol imwate muko mwai ethanol na methanol, then na glucose. Ethanol, methanol, glucose, they all contain carbon, hydrogen, and oxygen. All of them different. Glucose is that sugar which helps us to respire. The enzyme is broken down until it becomes glucose. Then our body needs that glucose to give us energy. Then eilenga wachwafye bwino wemuntu wamba minds out disrespect wasansa mukobufi wakwatotolo even methanol, which is methyl alcohol, is also very useful. This is ethanol and this is glucose. So now this is very useful because it's used as a solvent in industry when you're making a lot of things. Some things dissolve very easily in this one, the methanol. And they use it, they spike it. When you hear the word methylated spirit, to make this one, because umuntu kuchainwanga ili pure. To methanol, because methanol is poisonous, it causes blindness. But so that when you drink methylated spirit, you don't die instantly. But if you drink consistently, it actually makes you blind and destroys the organs. So those are the things. So I was saying we are concluding the topic, elements and compounds. If you do not understand, you don't know how to define any of these, if you can't define what an element is, what an atom, symbols, groups, by define, because someone asked me, how do you define alkali metals? There's nothing like it. You just have to know what they are. So to define alkali metals, you say alkali metals are group 1 elements on the periodic table. What are alkaline earth metals? These are group 2 elements on the periodic table. If you want to shine, you can even say they are group 1 elements on the periodic table and have the oxidation number of 1 when combined in compounds. Number even if you have group 1 elements, that's enough. Then the halogens, these are group 7 elements starting from fluorine, chlorine, and all those. So these are the ones that we use. So there's nothing more apart. If you could define what you want is for you to know them, so to apply them. So these are the ones. So even a subscript, someone asked me what's the definition. No one asked you for the definition of a subscript in a test. What are diatomic molecules? We already remember them. Which ones are diatomic? Those ones that exist in nature as a diatomic. You should just know them. So if someone says what are diatomic elements or molecules, you say these are molecules, e.g. hydrogen, oxygen, which exist in nature as diatomic. So try to simplify your reasoning than to make yourselves rigid. I think I've explained well. Are there any questions? Are there any questions? So what methods do non-metals use when sharing electrons? We'll go and revise this. To allow to research. Kaifa as a scientist, these people people have already found that non-metals share electrons. So your job is just to know that non-metals share electrons. To know what method they use, we have to look at molecular bonding in details. Guys, you're not asking questions. Should I release you? Because the topic is done, the notes will be coming soon. Should I release you? Kizito?
Oh, yes, sir. Oh,
Yes.
sorry, sir. I'll actually go out of the topic.
Yeah, it's okay.
I'll go out of the topic, sir. I was asking if you can send that table for conversion factors. The one which deals with conversions.
Okay. The table?
I was asking if you can send it in the group, sir.
Okay, I'll see. I'll see. Because I don't know, you even guide me. Guide me on WhatsApp.
Right, sir.
Guide me on WhatsApp what you really
I
want.
appreciate, sir.
I'm saying guide me on WhatsApp what you really want. I don't want to send something different. Anything else, guys?
Just the table for conversion factors.
Or table for conversion factors. Okay, I'll send. There's another. Kizito, switch off the mic. Shadrach, is there any question? Guys,
Sir.
you're not asking. Yes?
How was that? You don't send the recordings.
I've put something on. Have you heard what I've said, madam?
No, sir, I haven't hit.
Application.
I've sent something on YouTube.
Really, he just
3 videos of your Zoom.
So you've sent it on the study master, so we access
On
it from
YouTube.
there.
On YouTube.
And
But
then we just check for your name.
you can search my name, Chirungu Kandulo. But even on your study master, one of those is actually what your friends were learning in the morning. I've had time to edit now. What I didn't want was even like if today Sheria Shfedi Kadiaka, and then I did the video. Me push my bundles. So what I was summarizing, like I was cutting off some parts. Although
So even today's lecture will be there. Because me, I missed. So I didn't know that there's class. Then you log out of WhatsApp for 5 minutes, you find the class.
Oh yeah, sorry, man. Sorry,
So I'll find it on YouTube.
This is the patience?
Yes.
Okay. Because I can't really know who is talking because of the screen is enlarged. You've seen this, eh? So sometimes so to know ulelanda kwamba kumifuaya iji Bruno Mike naye Mike yakwa Bruno ile like it's off. This Bruno Chiumba. I can't know who is talking. That's the reason why Kuleba Ndepsha. Who is this? Who is this? Nshilapia sana Kai, as you know. I'm sure you've seen what.
yes. So it's muted here.
Okay. So now I'm guessing there are no more questions. Our next topic will be atomic structure. So go and read part atomic structure. Want to look at the protons, the electrons, and the neutrons, and then also want to look at electronic configurations and all those. So go and revise on atomic structure, all of you, to be ready. All right, guys, I'll release you because I think we've overextended this. And this is the one that I'll summarize because Nachalanda, we know if I made some mistakes there, I was mixing prefix and the subscript. Pa Facebook. Oh, na seven. Enjoy your day, guys. Have a lovely night. We have a class tomorrow at 8, physics. I would rather we look at the vectors again for tomorrow's lesson. I know we've introduced mechanics, but we look at vectors again because mule tumasana ma questions muna musha just up to now. So I'll try to explain. Let me prepare a sheet so that when I explain to you on the same vectors, it makes sense. So I'll just say tomorrow is vectors revision. So go through. I'll still continue to ask you, but tomorrow I'm doing vectors revision, especially the questions that I gave you. I'll be revising them myself. Then I'll put some notes because this time around I'm able to share the screen. I know what to do. Finally, minanga fiaka paper so tapare from hiyo. All right. Enjoy your day, guys. Good night. Have a lovely supper and take care of yourselves. Continue to take care of yourselves because COVID is real and it's great.
Thank you, sir.
All right. Cheers. Huh? Sharp.
Yes, sir. Madam Willow.
All right.